All right. In theory, we should be live. Well, so who watched the Starship launch today? Yeah. Anybody else? Does anybody not know what happened? Does anybody is
There's
this
so
a
many
spoiler for
things.
anybody?
I don't know what you're talking about.
You don't know what I'm talking about? Okay, great. Excellent. That's good. You're really immersing your studies then. That's the perfect answer. That was the craziest thing I've ever seen. I was just absolutely a stunning piece of aerospace history made today.
I didn't
Include
know what was supposed to be happening and what wasn't because I was just watching it cold. And so when those engines were cutting out during the test, I didn't know. It looked like it maybe caught on fire a little bit. So
yeah,
I
yeah,
had no idea.
yeah. We'll talk about this in the actual show a little more, but yeah, I think every. All right.
How big is the lag between what we're doing here and what appears on YouTube? Because
Uh,
I checked just now and it was like a time capsule. We're still going, but
yeah, it shouldn't be
Excellent.
that long. It's like a couple of seconds. Okay, back. Sorry about that. My internet just died. Like just went offline. Starlink. All right. But I think we're back. Uh, that was
Well,
weird.
I was in the midst of introducing myself, but I'll turn that privilege over to you, Fraser, if you'd like.
Yeah, were
I know.
you like there's if you were like trying to run the show, nobody could see you, but that was a valley. It was very professional.
You weren't sure.
Yeah, yeah. But you guys are still all in the Zoom meeting, so that's perfect. But no, that was very strange. Fortunately, we're only like a minute late, so we'll start the show. I'll put you guys all back in your boxes. There's me. All right, here we go. Hello and welcome to the Weekly Space Hangout for Wednesday, December 9th, 2020. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about the formation of the moon, all of the craziness coming in amateur astronomy, a galaxy that was stripped of its dark matter, and of course, we're going to be talking about today's Starship launch, as well as Hayabusa 2 and Chang'e 5 mission. Joining me this week, I've got Pam Hoffman. Hey, Pam, welcome back.
Hi, thanks, Fraser.
Oh, wait a second. There you are. You've got an all new camera setup.
Yep,
Awesome.
much better, huh?
Yeah, totally. All right, we've got Alan Versfeld. Hey, Alan.
hey, nice to be back after only 2 weeks.
Yeah, I know. And then we got Chris Carr. Hey, Chris.
Howdy.
I'm so glad you're able to take the time from your from the end of school, be able to join us. It's okay. It's okay. I mean, you're a total pro, but it's all right. You know, it's a question between studying, working on your your thesis, and us. Let us know.
I couldn't stay away.
The news was that important. I know. Um, all right. So before we get into this week's guest, I want to just give everyone a big reminder to go to the Weekly Space Hangout crew. These are, of course, our executive producers. They're the ones who call the shots, tell us what to do, organize us behind the scenes, and we couldn't do this without you. So go to wshcrew.space if you want to be a member of this incredible team. You'll be an executive producer of the show, and then you will be able to go and invite guests on the show, whoever you want, and they can't resist. They must come on the show if you send them the request, because you'll be an executive producer. So go to wshcrew.space. All right, let's get on to this week's special guest from the Planetary Society. We got Casey Dreier. Hey, Casey, welcome back.
Hey, it's been a while, I have to say. So it's nice to be back.
Yeah. What have you been up to? And for people who don't know, I mean, you've been at points. You were a contributor on this show. You've also come on as a special guest many times. Who are you? What do you do?
I'm the chief advocate and the senior space policy advisor at the Planetary Society. So I kind of wear two hats. I help organize our members to be active advocates in support of space exploration, particularly in the United States. And then I also do a lot of space policy development. So how do we build and structure the institutions that when they run, they spit out spacecraft on the other side?
Yeah.
How do we get from an idea to bending metal to building something that goes into space? Trying to develop the process behind that's space policy. So I'm also talk about it a lot. I try to demystify that whole process for folks and try to educate and empower people so they can not just enjoy space, but help make it better in the long run.
From an advocacy side, I got the chance to really watch you at work during the last couple of years as you were on Capitol Hill, knocking on doors, convincing people to join the various bills that would help improve the chances of various spacecraft launching. So it was like, how much of your work is just like specifically nagging people in politics to help vote for things in space exploration?
Well, I prefer to call it educating people.
Sure. Call it what you need.
Opportunity they have.
Yeah.
And, well, it's part of it. And so I have a colleague who's based in the DC area. I'm on the West Coast with the Planetary Society. We have a staff member based in Washington, DC. And it's really his day-to-day is showing up, well, before COVID, being there in person, shaking the hands, building those relationships. And so when something happens or we need action to be taken by a congressional office, we have that relationship, on behalf of, again, our members across the world. So we do an annual visit to Washington, D.C. It's called the Day of Action at the Planetary Society. That's for Americans from across the country. Last year from 28 different states, over 100 people flew in under their own dime to Washington, D.C. And we set up almost 200 meetings for them with their representatives and other members of Congress. And so that kind of in-person interaction, that's critical. I mean, they're called representatives for a reason, right? They're meant to represent you and they want to know what their constituents think. And it's our right to say, this is what we think a priority should be for our political system, to invest in space exploration, to invest in space science. And so I'd say that's, roughly a half of my work. And then the other half of it's really doing that, again, that flip side of like, what kind of policies are we asking them to do? Mm-hmm. What kind of ideas do we want them to do? How do we make space exploration happen more? How do we get better outcomes in the long run? And that's developing good policy, which then we try to build coalitions around to get people to buy in and support, and ultimately hope, enact, to the betterment of everybody. And that's kind of the other half of my job. And so again, I work really closely with my DC colleague, and then I get to kind of stay, kind of distant and observational, right? A remote sensing kind of situation for a lot of the politics in DC, and really focus on these big pictures. Because, we take it, at the Planetary Society, right? We're a membership-based organization. Anyone can be a member, but we don't take big amounts of corporate money. We don't have aerospace companies funding our operations. We don't take government money. And that really makes us one of the very few independent actors in the DC area advocating for space. And so we really consider ourselves kind of the voice of the people, because anyone can be a member. And that's a really important role to play. And that's something we really take seriously.
And then the other big role that you play, especially for me, is the person who demystifies the process of how laws get made. How something can go from we should send humans to the moon to here are the laws that are in place and what needs to happen so that funding will flow and rockets will actually get built. And you have an amazing podcast with the Planetary Radio. You guys do a space policy wonk edition on a regular basis. And it is one of my favorite things to listen to, because there's literally no one else who talks about it at this level of detail, and it's absolutely terrific. But I want to focus quickly on the news, because today was actually a very big day in space exploration from NASA anyway. Not to mention SpaceX, but we'll talk about that later.
Yeah, we had from a space policy perspective, it was the last meeting of this administration of the Space Policy Council, or the National Space Council, sorry. National Space Council was actually established when NASA was established in 1958 under the same law, the NASA Act. And it's meant to be a broad swath of government that originally was chaired by the president, now is chaired by the vice president, that's meant to kind of say we have a common space policy that's not just, individual agencies fighting for funding. And so you see on the membership of the council, it's like, you have the head of the labor secretary, right? You have the commerce secretary. You have NASA, obviously, administrator on there, right? So you have a broad swath and you have a defense representative. And so you have different aspects of government and all their ways that they intersect with space policy working together, chaired by the vice president. And, not every administration had decided to use this tool. And so the Trump administration had actually revived the Space Council after it had been dormant for about 25 years. And really put it to work, and it has done actually a surprisingly good job of developing decent policy. And it really kind of there's a rhetoric of what's the Trump administration been saying about space, but the actual work that they've been doing in the policy level is very decent policy. And so this was a little bit of a victory lap, I think we saw today by Pence. In the context of that National Space Council meeting, they introduced the Artemis astronaut corps.
Yeah, that was awesome.
Kind of cool, putting some, faces to this idea of going back to the moon. They introduced, I think more importantly from my world, the new national space policy. It's the formal document from the White House saying these are the goals and priorities of the United States when it comes to space. Now, people may say, well, we have a new administration about to come in, and that's true. But the last time a new national space policy had been made was 2010. So the Trump administration had actually been operating under Obama's national space policy with a few minor tweaks for almost its entire presidency. So these things, if they're written well, will be kind of the official stance on space. And so that was released today. I've been reading through some of it. It's we can talk about some of the details. Need more time to really soak it in. It's a long document. But these are big developments. This is kind of it's not just NASA, right? It's what the Department of Defense does. It's what the Commerce Secretary should do and how commerce should work with space. So it's a broad document that, again, tries to unify space within the U.S. government.
Based on the presentation that we saw today, how should people what will people expect to see over the next 4 years? Are we still going to try and hit that 2024 landing date for Artemis? And, is anything new or different that people should be keeping an eye on?
Yeah, well, obviously we'll have a new administration coming in on January 20th. And so, all of these things can change. It doesn't necessarily mean that they will. It just means that it could. And I would say, the Biden campaign put out very little in terms of space policy, which is actually kind of different than a lot of past, even, Clinton and others had put out some kind of statement about general goals and focus. The Biden campaign was really ultimately really laser focused on a few.
What? I lost your audio, Casey. Well, can you hear me okay? Yeah, Casey, sorry, I can't hear you now. Can anybody else hear him? There you go.
What's that?
Oh, there you go. You're back. Okay.
Did I cut out?
Yeah, your audio cut out. So, okay.
Okay.
Yeah.
Let me know that. You can flash me.
I wonder if my internet is still, if it's my internet with your internet, I'm not sure. Was he cutting out for anybody else? No, you sounded perfect. Okay. Oh, great. This is fun. Let's do an episode with unstable internet. Okay, please continue.
Well, the idea being that we can make some informed guesses about what we're likely to see coming up. And that doesn't mean it will or won't happen. It just means we're operating in an information deficit. The first and big picture, I think, is that we can look at the Democratic Party platform. This is the official kind of set of priorities of the party, which was endorsed by Biden back in the summer when he had his convention. And actually, they had a really great paragraph on space policy saying that humans should return to the moon and then go to Mars, that we should continue running the space station, that we should pursue space science and really increase our commitments to climate change and climate science. And that, that's important. So that adds some kind of sense of where they're thinking of what's important. So we're getting there, human space flight, International Space Station, and then climate. And in NASA, that's Earth Science Division. So I think it's very reasonable that, given the budget pressures that we'll be facing in the US, in addition to kind of not having this intense buy-in to NASA in the same way that the Trump administration did. And also, again, just being technically infeasible, the 2024 Artemis deadline is most likely going to be pushed back.
Yeah.
They'll maybe reconsider the project altogether, but I'd say at minimum, my guess is the 24 deadline is functionally gone. And it was kind of already, I think, just any honest observer looking at the program.
And so, I mean, this is the kind of thing that you guys talk about in your podcast, is just the signal that 2024 was probably not going to happen was the way funding needed to be released to the various NASA offices on time. And so the promises were made, the big speeches were had, but the funding wasn't actually flowing to the people who need it. And in my reporting, all the work that I was doing, I sort of heard this same message from person after person, which was, we're ready, but we kind of need that money.
Yeah, I mean, there's a saying something along the lines of, funding is policy, right? Budgets are policy, and it doesn't matter what you say, right? It matters, what you actually put your money towards. That's your non-zero, your zero sum kind of thing. Where do you put your priorities? And, to the credit of the administration, they had finally asked for more money for Artemis this year. They had asked for an increase of about $3 billion, all of it directed to particularly the lunar lander. Congress seems poised to give them maybe at best a third of that, right? And so, without that money, they didn't get all of what they asked for last year. They're very unlikely to get it this year. I mean, you don't go off to the store and just buy a lunar lander, right? You have to figure out how to build one. We haven't built one in 50 years. And that money, that investment, there's a whole cost curve over the time about when you need to put money into aerospace projects. And where you need to put money in is at the beginning, because you're designing it, you're figuring out how you're inventing new things, and you're figuring out what works and what doesn't. And the more people, you need lots of people in that process, and people cost money. And so you can look back to Apollo, and you can look at the cost of the command module, and it's this beautiful, or the Saturn V, it's this beautiful aerospace cost curve where it starts low at the beginning, ramps up, peaks about 2-3 years before it launched, and then starts going down as it moves into basically production. They figured out all the kinks, they can just start stamping these out. And what we're seeing with all the Artemis stuff is flat. Mm-hmm. And so you just don't have the resources to pursue it on the deadline that they wanted to. And so there's just, we're and this is classic, right? We tend to ask NASA to do things and then not give them the tools and resources to do it anymore. There's one exception to that.
And then blame them when they don't do it.
Yeah. And ultimately, ironically, it tends to cost more when that happens. Like, you just take the overall same amount of money, you just spread it out longer, but it's easier year to year to budget the money because you don't have to add a bunch one year and then, figure out where that's going to come from. So it's this frustrating thing. It's very common. And it's, I think, having, in a sense, a more realistic path. If you stretch out the deadline, you can lower the annual cost need for it, you give them more time. And, 2024, frankly, was already very ambitious, even if they had the money, right? I mean, they announced this a year ago, right? Like, let's not forget how recent this is, right? This is like early 2019 is when they decided to go through with this. And so we have, they kind of waited pretty far into a new administration, or into their administration, to turn gears and really amp this up. And the first couple of NASA budgets that they had asked for in the Trump administration, they actually requested to cut NASA funding. And so it's, not by a ton, but it's still somewhat. And so, there's only so much NASA can do to spin up and turn on a dime. And this is one of those things where an incoming Biden administration will have to look at the program and say, what's working, what doesn't, what fits in line with the priorities of this administration? Is this in line with our priorities for the nation, for our workforce goals or manufacturing, growth, whatever. And it might be. I think there's actually quite a few intersections between what Biden wants and what space can provide. And that's, again, it comes down to NASA is a tool of domestic policy. And it also can be a tool for international policy. You can use NASA to advance your national priorities. NASA is a great tool for ramping up industrial powerhouse, right? To bring new technologies, to bring people into STEM and science field.
I lost you again. You guys probably lost me. Sorry about this, everybody. I can still see Casey.
What's called the transition team right now.
It's back.
The Biden administration, or Biden incoming administration, I should say at this point, has these teams of people designated to basically kind of kick the tires, look under the hood and see what the deal is with all these federal agencies. One of them's for NASA. And they will kind of make a recommendation to the incoming administration saying, here's the problem areas, here's opportunities, here's what we think would be really great for the administration. And they're in the process of developing that now. And they'll lead into kind of what Biden ends up doing.
Yeah, so I guess that was my question was when can we expect to have some certainty again? When will we know which missions are going to move forward? When are we going to know that Nancy Grace Roman is off the chopping block or on the chopping block or whatever is going to happen? When should we see these big deadlines these next big milestones?
I would say look to mid-spring. So again, budgets are policy, right? And so what the standard process in the US is that we have the White House proposes a budget for the upcoming fiscal year. Usually in February, ideally of every single year, that Congress then takes as guidance and then funds or not, whatever they want to do with it, and then passes something into law around October, general ideal timeline.
Right.
But the White House budget request, even though it's not binding, is a statement of priorities. This is what we want to do. And a lot of the things, even if Congress, doesn't specifically change things, a lot of the things proposed in that tend to happen anyway. It's a very important document. And so we will look to, the incoming administration, when they take over in January, they'll have to look at the budget work that's been done, probably tweak it on its margins, to put some work onto it. They won't have a chance to do it all from scratch, but they'll put in important and remove important things. And so we'll look to that probably March. And so that'll give us our first indication. And then this following year, that's when we'll really see. That's when they have the whole time to develop their budget. And in between, of course, we'll see who the next administrator nominee is.
Right. Yeah. And we know that Bridenstine has said that he is going to step down. So do you have any guesses who's going to be the new NASA administrator?
Everyone has guesses and no one knows the answer.
Nobody
right?
knows. Okay.
People are talking, don't know, and the people who know aren't talking, generally is how these things go.
All right.
So it could be lots of names have been floated. I don't have any particular insight. There's, again, looking at who Biden has been nominating, you're probably going to see more of a strong topic expertise associated with a scientist or astronaut, much more likely.
Yeah.
Then, though I think Bridenstine has done a wonderful job coming in as an ex-congressperson. And so, but again, tends to be more of a kind of philosophy of the administration coming in. So that would be my guess. But again, that narrows it down to thousands of people.
It was funny, people asked me like what my opinion was of that. And I'm like, he was fine. He was actually okay. He was good. But at the same time, if I was like sit down and build my wish list of like the best possible people, I could probably think of some people who would be good too. So either way, well, I don't want to take any more of your time. We've got a pile of news to do. But if you enjoyed this kind of policy wonkery, this is what you get from Casey on the Planetary Radio podcast, as well as all the work that you're doing with the Planetary Society. Thank you so much for joining us today, and please let us know when we do find out more information, when people are going to go to the moon. Please let us know.
Sometime, I think.
Right.
I'll say definitively. Well, thank you for having me, Fraser.
All right, thanks, Casey.
Everybody, and I'll certainly happy to come back and talk more about it.
Awesome, man. All right, take care.
Bye.
All right, let's move on to the news this week. We'll save the Starship news and the other stuff to the end. Chris, you're on my screen right now. What have you got for us?
I feel like I'm always the first.
Are you always the first? We can put you elsewhere in the queue. So, okay, here's how this works. Whoever talked last is the person who is after the guest leaves, and they're the person who's on my screen, and I will always choose that person because that saves the uncomfortable camera switching. So if you have some like special, order that you want to rearrange the stack, that's the way you do it. There you go, behind the scenes. What do you got for us, man?
No, I'm already unmuted, so
Yeah.
So I'll be discussing the case of the missing dark matter. And so if you remember back an eternity ago, back in 2018, the astronomy community was buzzing with a group from Yale the Dragonfly group, claimed the discovery of a pair of dwarf galaxies that seem to be lacking dark matter. These galaxies go by the mouthful NGC 1052 DF2 and NGC 1052 DF4. So these galaxies are classified as ultra diffuse galaxies. So these are systems that have the size of about the Milky Way, but the luminosity of a dwarf galaxy. And these two were part of the NGC 1052 galaxy group, around 20 megaparsecs or around 60 million light years away. So needless to say, this discovery caused quite a stir, because dark matter, the invisible substance that we believe composes the vast majority of the mass in the universe, plays a central role in our theories of how galaxies form, because it is the gravity from dark matter that provides the initial seeds for galaxies to form. So the normal matter of stars and gas is sitting within the bind of the larger spherical dark matter halo. So the discovery of DF2 and DF4, these two galaxies that were lacking this vital substance, at the time seemed like a direct affront to our theories of how galaxies came to be. So that brings us to this recent work discussed in the article. And I think the article sums up the results quite well at the beginning when it says that these galaxies may not, in fact, be anomalies, but are the victims of theft.
Right.
So the dark matter that was there was taken. So this would be your time that you all gasp in unison.
Yeah, it's a crime. Yeah. So who stole their dark matter?
Yeah. So this work that was done, it was an international collaboration of astronomers. The lead was Ruia Montes of the University of New South Wales and from Australia. And so using these high resolution deep imaging from Hubble, they were able to capture some of the very faint features of stars and globular clusters that were to this point hidden from past observations. And so when you can look at the faint structure, you start to see evidence that some of these stars have been are in the process of being stripped away from DF4, likely from an event of tidal disruption from one of the nearby massive galaxies in the system. So stepping back to our picture of galaxy formation, it is that the dark matter halo that the galaxy sits in is the first that feels the gravitational attraction from any neighboring system, and is thus the first to be stripped away in any encounter. So what we're seeing now is we are witnessing the disruption of stars now with our telescopes that has already taken place with the dark matter long ago.
That's really interesting. So when we see some of these, like the tadpole galaxies, when we see galaxies that are clearly have gone through a fairly serious, some kind of tidal disruption, is it likely that their dark matter has been stripped away already? And so it's like seeing the stars stream away is like the last. I'm trying to think of a great analogy for this. It's a very evocative idea that when you see the crime, it's too late. It's already happened. The crime has already happened. The dark matter has been stolen. The galaxy has already been sort of extruded away to some other location, and it's the last thing to go is just the stars. I don't know. It's like some Looney Tunes, Anyway.
But because the great thing about tidal dwarfs is that they're an ideal test for whether or not the anomalies we see between dynamics and the matter is a result of hidden matter or a misunderstanding of gravity. Because if you can observe a tidal dwarf that had its dark matter stripped away, leaving just the luminous matter, then that tells you that this is something that can be turned off, that you can remove the hidden right. dark matter, the luminous matter. Because if this were a result of, say, a modified law of gravity, you can't turn that off.
Right. Yeah.
Whatever, like any observation will reveal the anomaly. So by finding galaxies that lack dark matter, you are thus proving dark matter's existence.
Right.
Which I think is another a very exciting thing about studying these tidal dwarfs in detail.
And vice versa too, though, finding galaxies that seem to be almost entirely dark matter or having very little luminous matter inside them as well. At this point, does modified gravity have any place left to hide at this point, or is it pretty overwhelmingly that it's
Only in my heart.
really modified gravity still gets you right there?
I gave up on it, but I just love the idea. It's just,
Yeah.
Yes. So I would actually say I'm somewhat more sympathetic towards modified gravity in the sense that I don't think you can completely rule it out yet. And it may just be because of my upbringing at Case in my undergrad. One of my advisors was a very strong modified advocate. So I guess some of that may have rubbed off on me so even though if you like put a gun to my head and ask me, does dark matter exist? I think the answer, I would clearly say yes. But there are successes of MOND on smaller galactic scales that have yet to be demonstrated clearly by the dark matter model that still need to be answered. So even though dark matter may in fact be there, there's still a lot about its interactions with galaxies that are still left to be unveiled.
And as always, when we see something like, say, Vera Rubin come online, some of these new big surveys that are starting to happen, we're going to get a chance to see a lot more examples of this that people can then use to try to more carefully extrapolate exactly where this stuff is and what's happening. Absolutely fascinating. I've mentioned this many times in the past that the thing I love about dark matter is that we're watching a mystery be figured out in real time. That for a lot of the other mysteries, like how does fusion in the sun work, or how does lightning work, or all these things that have been solved, and yet the one that is just nobody really knows what it is, and yet you're watching scientists chip away at the mysteries one by one to quantify it, and hopefully in our lifetimes we'll see it answered and we'll know what it was. And it was like, I don't know, quasars in the days of yore. So
it's a great time to be entering the field.
Yeah, it really is. I mean, yeah, I know for that and all the other issues in cosmology. Yeah, it's really good timing for you. Thanks, Chris. That was awesome. All right, Pam, tell us about the amazing meteor shower that's coming up.
Oh, we've got a whole bunch of things. And actually, just to go back a little bit, it was pretty quiet at the beginning of December. We just had bright planets, Mars and Saturn and Jupiter in the evening and Venus in the morning. That changes on December 12th with an occultation and 2 meteor showers and an eclipse later in the month and the Great Conjunction. I'm just going to go in chronological order. Yeah. How's that sound?
Yeah. No, and I apologize. We know there's a hum coming from Pam's microphone. We'll get that solved next time, but there's a lot of big news, so hang in there. We'll get through this quickly.
All right, on the 12th, there's an occultation of Venus, and it's actually going to be for most people on the planet during the daytime. And I would suggest you look for your location and when that's going to happen. And it's really cool because you can actually see Venus in the daytime. I've seen that. That's really
occultation
neat.
Of Venus by the moon?
Yes.
Okay.
The moon's going to come around and Venus will go behind it for a little while and then it'll come back out the other side. And I think it'd be a wonderful thing to take a look at. But yeah, like if you're really, really far north, extreme north in parts of Russia, in the Arctic, you're going to be able to see it in darkness. But yeah, mostly you're going to need a telescope, and I would check your location absolutely. Like I know from Earth Sky News in Hawaii, it's going to be fairly early in the mid-morning and then in the afternoon in California. But be really, really careful. This is fairly near the sun. You do not want to look at the sun through the telescope, especially or with your naked eye. That can be very dangerous to you. So with the caution in place, we're going to move on. December the 13th to the 14th overnight. That is going to be the Geminids meteor shower. There are 75 to 120 per hour. And it's actually a range for most of these. This one is December 4th through 17th. And, one of the ways to look at these is kind of perpendicular to their where they radiate from. And this one is Castor and Pollux, the Gemini asterism. Then you're going to see that after sunset, and these ones go all night, but especially around 2 a.m. That's the morning of the 14th. 14th also is a total solar eclipse. If you're in South America, like Chile or Argentina, but some people actually go onto the ocean. The Pacific, it comes kind of across the Pacific and then down through the bottom of South America and then over to the Atlantic. And you probably be able to see something online too. I didn't dig into that as much because there's a ton of stuff for this month.
So with the Geminids, I just want to back up for 1 second, which is
Sure.
that this is thought to be probably one of the best Geminids on record.
Oh, okay.
Yeah, so it's sort of in the way the orbits work with the Geminids are caused by an asteroid, not a comet. So all the other meteor showers are caused by comets, but the Geminids are caused by an asteroid. And the way the orbits and the way this asteroid is at Phaethon, the way it moves through the solar system, we're going to pass quite nicely through the trail that it leaves behind. Also, there's going to be a new moon. So this is probably going to be the best Geminids. It's not going to be an incredible storm like we've seen with the Leonids and other meteor showers in the past, but it still should be good and well with your time. Although for those of us in the northern hemisphere, it's going to be cold, which is why I don't like the Geminids.
Oh, I see.
Yeah. You're in California. You have no idea what it's like to be in
Southern California, but I'm from Northern Ohio, so I do have an idea.
All right. Then you do recall what a winter meteor
barely.
shower is like. Yeah.
Barely. So on the 16th and 17th, the moon is going to be near Jupiter and Saturn, and actually Pluto too, but you need a telescope to see that. And I kind of feel like it's shepherding in this great conjunction for the Jupiter and Saturn, which if you've been watching, they're kind of getting closer and closer, but they're kind of getting farther and farther west in the evening. So try and get out early.
Yeah.
Before that, though, December the 20th, Neptune and the moon are in conjunction. Also good with a telescope, and then the great conjunction.
Yeah. Now, I mean, anyone who's listening, every time you're on the show, we just keep talking about this, but this is the last time you're going to be here.
Yep.
So
till next year, I think. Yeah.
Yeah, but pitch the before the conjunction, the great conjunction. That's the new name, the great conjunction. I love it.
Like the great pumpkin. Yes.
Yeah.
So, and the kind of unique thing about this is they're both going to fit into the same view in a telescope. And again, this is happening kind of in the southwest, and I try to go out as early as possible and just kind of challenge myself. How early can I see these things? Of course, Jupiter, super, super bright. It is easily viewed fairly early. I think even when there's a little bit of light in the sky from the setting sun. And I would definitely say if you're not going to do anything else this month, check that one out.
Yeah.
Right.
They're going to be like an arc minute apart.
I think it's 0.6.
Yeah, and they're going to be visible in the same eyepiece. So that's a time saver. You just look in your telescope and you're looking at both Jupiter and Saturn at the same time. And the reality is that Saturn is going to disappear from the sky because it's visibly so close to Jupiter that we won't even be able to really see it.
And it's fairly dim, and they're both going to keep heading into the west. But I have some more about that a little bit later on. And this list is huge. We can stop anytime.
Okay. Well, we should probably. Was there anything else? And then we should probably move on.
I'll tell you what. I will add this list to the chat after.
Yep.
But yeah, it's huge. It's huge.
All right. Thanks. Okay, Alan. Last but not least, what have you got for us?
Yeah, it's a bit of interesting work where some numerical simulations, they reckon they've cracked how the moon formed.
How did the moon... Okay, I'll bite.
Well,
how did the moon form?
In more detail. I don't think it's the first time someone's tried this, but... So, just a bit of a recap. Current theory is of how the moon formed is... there have been a number of ideas over the years, but one, I think that the current standing one is it was a collision. A proto-Earth, a little bit smaller than Earth now, collided with an object around about the size of Mars, which we call Theia, and the resulting debris all coalesced and formed into the moon. And there have been a lot of simulations which have led to those sizes. But some people make it work, some people don't. So what this team of astronomers from the University of Durham in the UK have done, and I assume I pronounced that right, their simulation has taken into account spin. And they ran a number of simulations using those two masses, where they collided everything from a square, clean head-on collision to a very glancing one and everything in between. And then through a range of different spin rates between the different of the different objects, from almost no spin at all to a very rapid spin, because you can only spin so fast, because then objects start to fly apart. And they found values where you end up with a large cloud of debris, which is more or less the same mass as the moon, and which coalesces to form an object roughly the same mass as the moon, which has about 1% iron, and which mostly at the core is the original impactor, and as you get close to the surface is more and more rock from Earth, which is pretty much what
that was amazing in that simulation, was the number of hours they were showing that the moon formed. It was like 72 hours.
That's quick.
Right? Yeah, like I would not think that you would have a moon, like after that collision, you would have a moon within, a couple of days. But it formed
Well, you mentioned the speed. I was going to say this for the end because it's kind of peripheral, but what really impressed me about this was the simulation code itself. You always hear about these kinds of numerical work. The code ran for so many weeks on a big supercomputer in a university. This runs about, I think I said 7 minutes on a desktop PC.
Oh wow!
Which I'm assuming that's per run. They didn't do the complete work. But yeah, it's really it's amazing. But I think what was interesting is they found that the most sensitive variable is the spin.
Mm-hmm.
Right. It was the spin that had the greatest effect on whether or not you get something that actually ends up orbiting Earth and coalescing into a structure that looks like the moon.
Now, the spin of the Earth or the spin of the impactor?
It seems to be the impactor, if I've read the paper correctly.
Okay.
And you think about it, that makes a lot of sense because, collisions between round objects, like think about a pool table, right? Lining up your trick shots or what have you. Amateurs just hit the ball. People like me, we just hit it, hit it with a long stick. But the pros really work on the spin, and they can make things arc. They can get all kinds of interesting results because that angular momentum, especially on something the size of a planet, that is an enormous reservoir of energy, which is going to affect the outcome. And this is where I was going to talk about how quick the simulation ran, but we've already covered that. So.
Right.
I wish my simulations ran that fast.
Well, they've put it up on GitHub if you want to download it and try it yourself. There's even a Python module that they've released. So.
And then just like replace Theia with a galaxy, and then replace Earth with another galaxy, and I'm sure the particle simulation should work out about the same. It's just gravity. Yeah, adjusting for dark matter, it should work out okay. Yeah. A few changed variables, it should be fine. So, how does this research change at all our thinking about the formation of the moon? Because at this point, I think the consensus is the moon formed when a Mars-sized object crashed into the Earth.
It doesn't confirm what happened. Obviously, these are just simulations of something that happened billions of years ago. But I think this narrows the constraints as to how it could have formed, and it provides scenarios that match what we are seeing.
So it's like if you crash a bunch of simulated Theias into the Earth, if you get the conditions right, you get the moon quite nicely.
Yeah. Of course, it is a problem with this kind of work is that you can always come up with a theory after the fact to match what you've seen. Hopefully this will result in some new information that we can then use a prediction that we can then go back and test and look for more data and see if what the simulation predicts is in fact what we've seen or what we didn't know about before. That would be, I think, would be the gold standard.
It's interesting to think when you sort of think about what the early solar system must have looked like with this is evidence of one of these giant collisions that we see, but when we look at like how Ryugu and other asteroids are just these jumbly rock piles that have just been mixed and churned and smashed and crashed multiple times. That what caused Theia was probably, or what caused the moon was just the beginning of a long line of these giant catastrophic impacts that happened to planet Earth. And then, and maybe you wonder, like, maybe why didn't we have more moons? And maybe it comes back to that rotation concept.
Could be. Or even just the mass of the moon itself could have destabilized anything else that tries to form around the Earth.
Yeah, I mean, I think one of the other big mysteries that's still there is, like, why did the halves of the moon look so different? That the front side, you see just the mare, all of the lava flows, and then on the backside, it just looks completely different, like just a cratered mess. But you don't see those.
I understand
seas.
that's. Sorry, Chris, you wanted to say?
Yeah, I was going to take a stab at that. If
Yeah.
you, or unless Alan, you're proficient.
No, hit it, Chris. Let's hear it
first. Yeah.
Yeah, so that was something that I also wondered about, like why are the different sides of the moon so different? I remember wondering about this like back in high school, and so I remember the answer to this quite vividly, so it kind of stuck with me. So the reason why is because since when the moon and Earth were a lot closer, they were tidally locked, and so one side of the moon was constantly facing like this scorched Earth that was constantly like blasting that side of the moon with heat and energy, and so that side of the moon was a lot softer compared to the other side of the moon, which wasn't being exposed to these blinding heat rays. And so during the period of Great Bombardment, when all these meteorites are crashing into the moon, the side that was softer, which was the side facing the Earth, was more easily penetrated by that bombardment, allowing the early lunar lava flows to bubbling up beneath the surface to settle on the surface and then eventually cool to form the black maria on one side of the moon, leaving the other side relatively unpaved by the maria.
That's really interesting.
That is much more complete than what I was going to guess. Yeah.
Yeah, well, I hadn't heard that. I mean, the one theory that I had heard, clearly we need to have a planetary scientist in with us, was that there was in the past another moon that was part of that had merged with the moon and did that same thing, essentially thickened the backside of the moon and then made it less prone to having those the volcanic eruptions on the side that's facing the Earth. But absolutely fascinating. All right, so there's a couple of really, really big... Oh, thanks, Alan. There's a couple of really big stories that I thought we would sort of tackle as a bit of a roundtable if you guys want, which is that there was a couple of big stories that happened just over the weekend. We would just be completely remiss to not talk about it. The first, of course, is Hayabusa 2 returned over the weekend, delivered its sample to the Australian outback, and we've got some great pictures of the researchers in Australia, in Woomera, picking up the samples carefully and retrieving them. So just huge congratulations to everyone with JAXA and the team on carrying out just an incredible mission. I'm such a fan of how they run their missions. When you think about what they did with Hayabusa, that they threw rovers, hoppers, they shot it with a tank shell, retrieved a sample, brought the sample back home to Earth. It all went without a hitch. And now Hayabusa 2 is off to its next target. So we got that this weekend. I don't know if anybody had anything to add about that. Yeah, Pam?
1 gram, though. That seems like a lot of ride for a very short...
It beats the previous. Hayabusa 1 brought back like a fraction of a gram. So this is definitely an improvement over what happened with Hayabusa 1. Of course, the other big piece of news this weekend was the Chinese Chang'e 5 mission. Again, went absolutely perfectly, landed. I think maybe it was during Astronomy Cast we showed the actual landing. But anyway, they landed on the moon, retrieved their sample, drilled into the regolith, extracted those samples, put it onto their ascender. The ascender launched from the surface of the moon, docked with the return vehicle, And then the ascender crashed back down to the moon. And now we're expecting the return vehicle to come back on the 16th. So essentially, during the next weekly space hangout, we'll know whether or not they were able to successfully retrieve their sample of the moon. And this is the first lunar sample that we've seen in over 40 years. I was like 1976 when the Soviets had their last mission. And hopefully we'll see. Hopefully they'll share. It'd be nice to see because this was a different, fresh region where they were exploring. But congratulations to everybody involved in that mission. And then the last thing, we got a couple more minutes, so I wanted to share the Starship. So today we watched Starship. Here, let me just bring this up. I'll share this with my co-hosts so you can all see. So today we watched Starship launch from Boca Chica, Texas. Yesterday they tried to launch, but then they had to scrub the launch, and we watched it lose all of its. They sort of detanked it and tried again today. Today they tried. They had a hold about an hour before they actually did the launch, and then they actually did the launch. And the first part of it went great. Of course, this is the Starship with its three. It's very loud. With its three methane-breathing or methane-firing propelled Raptor engines, full flow. The rocket took off beautifully, went up to a pretty high altitude. We'll sort of scrub past that part. It's a little boring. We got to a point where, let's see, where's the part here? They turned off one of the engines. So they'd reached their altitude. They started to slow down the rocket. They turned off one of the engines. Then they turned off the other engine. So they were just down to one engine, and then you can see sort of as the trail behind it started to stop gaining altitude. And then they did this incredible flip maneuver. And this is the thing that I think we were all waiting to actually see them pull off, so that the rocket could then put itself into a belly flop maneuver, and then just started to fall back to Earth. And hopefully we'll get a chance to see the actual flop. Right about here. It's quite quick, so I don't want to scrub too far. But it was very impressive that this part of it worked. And then, of course, the whole point with the Starship is that when it, as it's returning back to Earth, it comes through the atmosphere, bleeds off all that orbital velocity using that sort of face-on side, and then here it is, and then falls back to Earth, reaching terminal velocity. And so the whole point of flying this rocket at up to the 12.5 kilometers altitude that they did today was for it to get to terminal velocity as it was falling down. And so it's balancing out the front and the back. And this is something that the Falcon rocket just doesn't do, is that it doesn't perform the same kind of operation where it falls sideways. And you can actually see it getting, and I'll sort of scrub a little forward again. We see it getting closer and closer. Oh, wait, here we go. All right. Made it through the clouds. There's a little bit of a spoiler there. And then at the last minute, they start up the engines. This was a big moment. It does this incredible reposition, fires its engines, lands, and explodes.
Up until that landing, it looks like every bad Kerbal Space launch.
Yeah, I know. That is every one of my my Kerbal Space launches. So what happened? So from what we know, I'll stop that there. Okay, so from what we know, Starship is built with it has the main methane tanks, but it has a second tank up in the nose area, and the purpose of the tank is only for that landing maneuver. And so the spacecraft, because when it's falling sideways, the propellant is sort of is sitting sideways inside the rocket, and so they can't pull it out of the main rocket quickly enough and in the right way they need. So they have a special pressurized tank at the top that's just used for this landing maneuver. And the rocket was able to ignite with this header tank, so that worked. But they didn't have enough pressure in that tank to pump fuel out the rocket, out the engines quickly enough for it to be able to slow down and land safely. But every other part of this went off without a hitch. For the first time, we saw 3 engines fire in concert. It carried it to a very high altitude. It was able to perform that flip, turn off its engines one at a time, perform that flip maneuver, and return to Earth. The part that didn't work was getting the right pressure out of that header tank so that it could actually safely land. So, understandably, everybody associated with the mission is pretty excited. I think it worked as well as they could have hoped. I mean, obviously, it would have been nice if it did land, but this was still, I think, considered a tremendous success. And I suspect SN9 will be the one that actually pulls off the safe landing. You're up next, SN9. 8 have gone before you.
Do you know when that is, Fraser?
No, we don't know. We don't know when the next one is gonna take off. But at this point, there's going to be a bunch of tests. I think they've got SN9 through 11 in various phases of construction, and probably spring next year we're going to watch one attempt to go orbital, and then we have a whole new set of challenges as these things attempt to bleed off orbital velocity, returning to back to the landing pad. So that's a whole other level of energy that so far we haven't even seen. I mean, to just go up and come back down, that's just such a fraction of the energies involved of going orbital velocities. But still, absolutely phenomenal. I'm going to put you guys all back. Oh, no. Okay, so Pam, you're on my screen right now. Where can people find out more, and what are you working on?
We are doing a Friday night live on Facebook at 9 p.m. Pacific time, midnight Eastern time, and we've got guests, which is really fun. I'm so sorry.
Someone really wants to call you during.
I think so, yeah.
Yeah.
And that's going really well. We're going to have David Renicky from Australia on Friday. That's 2 nights from tonight.
Fantastic.
And also my book. So
Whoa.
Anybody Explore Space Now book is still available on Amazon, and there's a way to get it for free if you want to ask me, and I'll put some information
right on.
Also in the chat. Thanks, Fraser.
All right, Alan, what are you working on? Where can people find out more?
Yeah, so as always, the Urban Astronomer podcast, still threatening to resume that current season. Yeah.
Podcasting is hard. COVID, I know. Time has no meaning.
So it's funny, all the material is recorded. I just need to edit it and release it. But any day now, you can go and have a look at the website at urban-astronomer.com. You'll see it as soon as it comes out. Or just subscribe to it. It'll sit there quietly until I'm done. That's it.
Okay, Chris.
That's what I'm on, yeah.
What are you working on?
Well, right now, homework and class projects. But if you want to follow me, you can follow me on Twitter at @TheRealCCar. Eventually, I'll start doing other things.
Yeah, no, it's important to focus here at this point in your education.
When are you done, Chris?
Well, with the semester?
Oh, okay. So you've got some years on you still.
When do you get your PhD? That's the question.
Probably 4 or 5 years.
Oh wow.
Yeah.
What is it exactly? What's the PhD?
A PhD in astronomy.
Yeah, I've warned you though that the Weekly Space Hangout is a PhD factory. So it's really just inevitable at this point. You really just need to show up.
That's good news.
Yeah, absolutely. We've
I'd like a PhD in astronomy.
We've minted many PhDs in astronomy around these parts. So
okay.
Yeah, no problem. Nicole Gallucci, Kim Cartier, Morgan Renberg, they all got their PhDs on our watch. So yeah, we take the show takes full responsibility. All right, I'm going to put everybody back on the screens. On Friday morning, I'm going to be interviewing Elizabeth Howell, fellow Canadian, and we're going to be talking about Canadarms and Collaborations, which is the story of Canadian space. That's backwards. Hold on. Canadian space exploration. So if you ever want to know why we're so into putting arms on things, we'll be talking about that on Friday. All right, there's everybody back there. Thank you, everybody, for joining us today for this episode. We've got one more episode next week, and then we have, I think, a 2-week break after that for the holidays. So definitely come back next week for the 16th. Yeah. All right. Thank you to all of the moderators. Thank you to Nancy for organizing everything. Thanks for everybody watching us both on YouTube and on Twitch if you're there as well. And thanks to my co-hosts. And we will see all of you next week. And then for my co-hosts, some combination of you, I think next year. It's been a pleasure saying goodbye to 2020. We'll see you in 2021, which is going to be like the best year.
Yay.
All right. Thanks, everybody.
Thank you, Fraser.
Bye-bye.
Bye-bye.